Okay. So are you gonna just make this a front adder panel or a back? What do you want to make it? Yeah, we hear you. We hear you. Barry. So Robert, we can either make this a back or we can make this a front adder panel. It's totally up to you.
I'll prefer front.
Okay, let's make it an adder panel so it's not overlaid on that 3/4. All right, so we need a construction principle and a part definition, right?
Do I have to have underscore
You do not.
in the name of? You do not, right?
No, you do not. Only place you have to have an underscore is the order name or a variable name. Other than that, you can use spaces.
Okay. What about special signs like slash?
It's not going to let you use like a plus, a dash, a slash, or an asterisk because those are actually mathematical operators.
Okay.
You can use some special characters, but not those 4.
All right. Maybe I'll even do this. Oh, that's fine.
Right. So we might as well go ahead and kill the line boring. We don't need that. Okay, so we will need a part definition, so we can call that material and add our machining, right?
So category, probably we'll use panel, as there is something more.
You could use toe kick. I mean, really, all that really does is affects that little picture you see in the bottom right there.
Okay, yeah, that makes sense.
All right, save that. Save it first. Add it to your list. There you go. Now pick the material.
Okay, material. I'll say maple ply. I want a solid wood.
If you're looking for some solid wood, look in the frameless folder.
Okay. There's solid wood. 3/4. Either maple. Yeah, maple. I think best.
Okay, so try that 4/4 WD1. Just a generic, but you can name it whatever you want to.
Should I put any description on it? I guess no.
It's totally up to you. I mean, WD1 is just kind of a generic name. So it could be any species. If you want it to be a specific species, just go ahead and make it.
No, I guess not, because sometimes this is painted, so it could be poplar. It doesn't have to be maple.
Okay. All right, so how wide are these slots?
So I want to have them be half-inch high, I would say, or half-inch diameter cut, and starting with 2 inches from edge from each side. And
Okay.
from the bottom.
I'm just gonna make just a groove for the. Excuse me. Just with a 1/2 inch bit.
That's right.
Okay.
So the bottom one, I would like to have 3/4 of the floor, 1/2 inch groove, then 1/2 inch space, 1/2 inch groove, 1/2 inch space, and 1/2 inch groove.
Okay.
So it's going to be centered on the board.
All right. So let's add a groove there. And we want to do a linear division. Start point X, how far from
2 inches from the edge. This is from left to right side, correct? When I'm
correct.
looking at the face.
So you're looking at the face, so 2 inches to 1 for a start point. Okay, and then coming up from the bottom. So you want how much? You want equal
3/4.
space,
It will be eventually. It will be equal.
okay, so let's start out with just 1, and then 1/2 inch on center in between.
Yes.
Okay, so 1 to a 1/2 inch to a 1/2 inch to a 1/2 inch to 1. Let's see, is that going to work? Just to the center. You want a 1/2 inch space between the grooves? Is that what you want?
Yes, 1/2 inch space, 1/2 inch groove, and 1/2 inch space between it.
Okay, so this works off the center. So let's go 1 to 1 inch to 1 inch to 1 inch to 1. These work off the center. So if you want a 1/2 inch spacing, you got a 1/2 inch groove. You got to have a 1 inch to 1 inch to 1 inch. Don't forget your inch. That's what they would be on center, right? Inch apart.
Yes, correct.
Okay. And then to 1. 2, 3. We have 5 spaces. 1, 2. We only need 4 spaces.
So if we go from the center, we have to the bottom will be 1 inch, to the bottom slot 1 inch, then to the upper slot 1 inch, and then from bottom slot to the floor or to the bottom of the toe kick.
Yeah, I get it. We have one too many 1 inch in there. Get rid of one of the 1 inches. There's only 3 slots. We got 4 there.
One, two, three. So each column represents a slot, right?
Yeah, each number represents a space. Each column represents a slot. Okay, start point Z. We've got our orientation on the bottom. So what's our start point? Do you remember this? All right, so write it down again. If you're working off the bottom, start point Z is going to be 0 to 1. If you're working off the top, 1 to 0. Okay, so you want to work off the top, you have to change your orientation. Right now you're on the bottom. You see that? You see orientation? The very top of this says bottom. Nope, back on the groove. You see where it says orientation, Robert?
Yes.
You see right above that it says you're on the bottom? It says BOT?
Yep. Yes.
So open that.
So
Yep, open that orientation. You can change it to the top. That's fine.
I'll keep it at bottom because I'm getting confused now.
Okay.
So bottom should be 0 to 1.
That's correct. It just defaults to bottom. You can select whatever you want. It's a piece of hardwood, so it's not really going to matter that much.
Okay.
All right. Endpoint X, 1 to 2 inches, right? 2 inches on the start, 2 inches on the end.
Correct.
Oh, 1 to 2 inches. You already have 2 inches to 1 for a start. Now we're going to end 1 to 2 inches off the other end. Don't forget your IN. All right. End point Y is going to be the same as start point Y. The start and end in the same Y location, correct?
That's correct.
No, start point Y, not X. Look up there at your start point Y.
Hey Larry, why would we have a start and an end on the Y if we want to go up in an angle?
Yes, you want to go at an angle, you'd have a different end point in Y.
Okay, got you.
Or if you were routing in Y, then you'd have the same start point in X and different endpoints in Y.
Okay.
Okay, endpoint Z is the same as the start point Z. Robert, Z.
Oh, jeez. I'm looking at.
All right, depth.
0.75.
You don't need inches. And then the width of it, 1/2 inch.
Yes. Wait a minute. That's about toe kick, right? The whole material. So it'll be.
Oh, this is the width of the groove that you're making. Yeah.
0.5.
Okay. And then edge profile. Remember, you can hit that ellipsis and pick the tool you want to use. So if you scroll up in your list there, you should have some tools set up. First folder. Okay. And machine definition, it's a mill, not a saw. And end type, if you wanted to look around it on the end, you can pick around there. Grid reference for routing an X.
Hey Larry, the square and the rounded edge is just for visuals when you produce the drawings.
Just for the visuals, yeah.
Yeah,
we know it's
sometimes the client.
Yeah, we know it's going to have a rounded end when we run it on the router, but for visually, you can show it square or round or just say undefined.
Yeah, some clients want it squared. So yeah, okay, good. Thanks.
All right, let's save and apply. See what we got. Screen check it, draw it up. If we're anywhere in the ballpark. Well, I did you no good because you canceled. New top view article, my man. If you cancel out before you finish drawing it, it didn't make anything. Height, width, depth. Luckily for you, it's a live database, right?
Yep.
Put your front back on. Adder panel. And hopefully it's in the drop down. Check the drop down there. There we go. Now this time finish drawing it before you escape out. Hit enter. Screen check how to work. All right, let's see the front view. Okay, turn 3D workings on. We got nothing. All right, let's go take a look at it. Element manager, let's go to your part definition. Actually, just modify an article. Maybe you didn't get the part definition assigned. Okay, let's go look at our part definition. And that all looks good. So what else could it possibly be? Anybody? He's got his part assigned, he's got his machining on it, but he's not seeing anything. What could possibly cause that?
Visual manager.
There you go. Go check your Visio manager. Let's close out. That seems okay. Hit your ellipsis there by the render visualization.
Here on the
Next one down.
what is that? Oh.
Everything is turned on. All right, give me keyboard and mouse. We'll take a look at it. Everything seems fine.
Yeah. Mine is the same way.
End type was round before. Did it change itself?
It shouldn't really matter.
No, I know, but just curious why it changed.
Mm-hmm. Oh, things just stucky. You could do that. What have you done, Robert?
I wish I knew.
Ew.
Yeah, Ron. I'm checking in on you. How's things going? Everything's good? You keep busy?
Henry just really.
Oh, okay. All right. All right, I'll be all right. You know, if you need anything, I'm free. Okay, man. Thank you.
A little bit, I know. Dope. heck? I think we got X and Y flipped is all it is. Yep. Forgot it's the front, so it's rotated. All right, so what you need to do is just flip your X and Y's around. So switch your start point X and Y and your end point X and Y there. This is rotated 90 degrees. So this would be side to side, top to bottom.
Why is that then?
Because it's a front, it's rotated 90 degrees to the right, laid on its side. So this is actually the bottom, this is the right side, this is the left side, this is the top. So X is, since it's a vertical grain, it's a front, so you know your X is actually this way. Y is this way. Trust me, just flip these values around. Part definition is based on how you use it.
Okay, so 2 is the top, right?
Two is the top, correct. Just reverse your X and Y's. Put what you have in X and Y, what you have in Y and X. Since it was only 4 inches tall, there was nothing for it to do. End point also, flip those. All right, save that, close and refresh. Or modify your article and change it back to 4 inches.
Nice.
There we go. My bad, sorry. Of course, save that to your library so you got it.
Go back to modify article.
Yep, modify article, hit the save button. See what it means.
Rudy wants to go back to the part definition.
Yep. So since this is used as a front, it's rotated 90 degrees. So as you look at the picture, 4 would be the bottom of the part, 2 would be the top. So from bottom to top, I'm going to go 1 to 1 inch to 1 inch to 1. 3 would be the left side, 1 would be the right side. So that's why that's the Y, 2 inches to 1 and 1 to 2 inches.
Okay. Yep. All good?
Yeah, I got it, but mine's not drawing.
All right, let's take a look at you, Rudy. See what you got. and show your screen. Okay, that looks fine. Did you check your Vision Manager?
Yeah. Does this do anything? Virtual?
Yeah, that makes it a virtual part, so it's not going to get cut.
Okay.
Go ahead and hit go ahead and hit your ellipsis there and make some manufacturing information for it. Yep. So rename this to top. Oh, rename it to top, please. Okay, save it. Part name, what will you call the part? Oh, go back. Hit enter to take that. You want to check all three of those boxes. Part in the bill of material, part and cut list, generate CNC program. All right, save and apply that. Yep, save, apply. All right, and let's check your Vision Manager. Let's see your keyboard and mouse review.
Are we cooking this one?
Yeah. Oh, there we go.
Looks good.
Thank you.
All right, you got that saved off, Robert?
I'll do it now.
Come back to you, Robert.
Okay.
Do you remember how to make a preview picture so it shows up over here?
Preview picture.
Yeah. So when you select this guy, okay, what's what you call it? So you get a little
Yeah.
picture of it down here. So select it from your list and say select preview. There's my preview. Ooh. What's going on with this? Oops, that's my computer. Can you give me a Windows Explorer?
Give you what? I'm sorry.
Folder, Windows Explorer.
I cannot hear, Larry.
Go to my computer. Oh, it's hidden. Okay. Why are you not showing up? Looking in the wrong place. I'm not sure why that's not showing up. It's in the right location. Let's see if we just run a test here. Come on. Is this you, Rudy? Base Grill?
I think that's his.
Yeah, it's weird. His showing up and yours isn't.
Might be because I didn't make those steps that he was applying changes with the name of the article and a few other steps.
Doesn't matter.
I thought, yeah.
If I say make that a preview, it could be anything. Yours isn't even showing up.
I wonder because actually when I pick from the library any article, they are not showing up either. I should have preview on the bottom, but I don't get it all the time.
It looks like it's making it, but where the heck is it going? Yeah, I'm not sure what controls that. Another preview. Yeah, I'm not sure. You might have to check with tech support. It looks like it's creating it, but definitely not there. Should go to this folder. It's not here. just not getting there. All right. I mean, Robert, I would say put in a order to tech support. Have them check that out. It's just this looks like it's creating it. I don't know where the hell it's going.
Okay. What about you, Ray?
Rudy's worked fine, but
Oh, so that was yours, not Rudy's. Okay, so right. So I was wondering, this is only me. So what I was telling you, Larry, that when you pick article from the library, we don't get previews.
nothing toe kick in there at all. I mean, it's just got to be a path issue, I'm sure. Who made this one?
Ray.
So Ray's path's correct. Yours isn't. That's all. Yeah, it's just a path issue, so I'm not sure what controls it, to be honest with you. All right, well, we'll dig into it a little bit. What else we got?
We'd like to know how to control. Let's say we have cabinet with few shelves. We want to make shelves evenly spaced in the cabinet, and each shelf to have 5 holes only, for example. So control holes for shelves individually instead of having full string of holes in the cabinet.
Okay. All right, so that would be a little different scenario. So
Oh, so even a Tokic part now, it's in the wrong view.
all right, so right now you've got this set up with your end panels as full line boring. Which you don't want. Let's see. Do I have any here with no line boring? We'll just make one. You dog. So you want to have some sides that don't have the full line boring on them already.
Yes.
Okay. And then you'd want to use a shelf that had a connection situation where the line boring was done. So right now your default variable it has this connection situation, adjustable shelf, no drill. I believe this one, it has a connection situation where the drilling's actually coming in with the shelf pins. And I think it has 5 assigned to it. Okay.
So now if we add another shelf to this cabinet,
Yeah, you would
we
get
have
5.
to,
Yep. So if we went 1 into 1 to 1, you'd have 5 per shelf. So what you could do, since your defaults have the side panels and the shelves as variables, then you could you just have to create the side panels like we did with no line boring and switch
Okay.
out the variables. So if I come in here and I say, hey, I want so it doesn't require you to really change all of your cabinets and resave them. So now you can make an order related variable. And, BU side left. We'll pick the no line board for the job. And of course, the same for all your cabinets, whatever you want to change. Or you can do it article by article. I'll just set it up for the whole order. And where are you at? Instruction settings. Configuration here. I can't remember where this guy's at. Apply that for now. Okay, here I'm with some line board. So you have to change out your adjustable shelf variable.
but I'm not going to mess up here my library, right? This is only for this particular cabinet or job.
only for this order or the particular cabinet as needed. This still leaves your default. Crap. So we want this guy. So we really didn't change the construction of your case at all. We just switched out the actual parts assigned to the variables. Now the reason this has 5, let's look at that real quick so you can understand that. So it has a connection situation where the drilling is actually part of the shelf pin. You see it still says TP80J. This has a so this guy is pulling up the project shelf clip, which doesn't have any drilling.
Hello?
This guy's pulling up the shelf clip that does have drilling, so they can track him down.
Hey Larry, can you explain what you're doing?
Yeah, so I'm just looking for what's being used on this particular connection. It's set to a connection scan, so it's using whatever's been used the most. And you can see that there are numbers set up in here. So this one says LR3, so that one has 3 holes. This one has 5 holes. These two have 1, 1, 3, 5, 1, 3, 5.
Is there any manual
This is probably what's
that would
been used.
explain?
Yeah, go ahead.
Is there any manual that would explain all the letters that are used? Description of.
I wish.
Because I mean, I know that eventually we will figure this out, but right now every part, every construction principle has its specific name. Actually, just a bunch of letters. So at first glance, it doesn't mean much to us.
Yep, I know exactly what you're saying. I wish I could help you. There are lots in here that I don't even know. I have to go look at them and see what they are. The thing is, they have a program they use when they compile the program and they add new hardware, and this program takes information from the manufacturer and creates all these connectors, connector sets, and connection situations. So it has some algorithm that creates all these names that just don't mean anything to me.
Okay.
So the one that's attached to the one you're using is this. There's a variable for the shelf clip selection. And by default, it has this hateful spoon type, which has, may remember in the work group, our work group name, so this has con null, so it has no machining on it at all. When you switch to the other one, I believe it's using this one, which has this work group, which has 5 holes on it. 1, 2, 3, 4, 5. Of course, you could set one up with 3, 5, 7, 9, however many you want to have. So that's really the difference. It's which connector is actually being used. The one that's set up as the default doesn't have machining because you're doing full line boring. If you don't want to do full line boring, then you have to pick that other shelf and it automatically has the 5 holes set to it. But we can make it however many holes you want.
All right, not that this is our standard, but quite often customers like to have just a couple of holes per shelf.
Right, so this one that's it's being used has the 5 holes, so it has 1 and 0, 0, so the insertion point. And it has one positive 32. I'm sure this one's negative 32. And there's probably a positive 64 and a negative 64. Remember when we did the handle? We got to tell it exactly where to drill the holes. That's all we're doing here.
Right.
Based on where that shelf pin's coming in at, we're getting 1 at 0, 0, the insertion, 1 up 32, 1 up 64, 1 down 32, 1 down 64. Giving you a total of 5 holes. Versus the shelf that you're using for full line boring uses this Hayfliss spoon type, which has no holes because you're doing full line boring. But it's pre-set up. You can change it at the order value. You just need side panels with no line boring and pick that particular shelf for the adjustable shelf.
Okay.
Does that make sense to you, Robert?
It does.
You're not really affecting your construction. You're just changing out, which side panels are being used, which shelf's being used. That's all.
Right. And then the holes are assigned to the shelf instead of to the cabinet.
Yeah, the holes are actually assigned to the shelf pin or the shelf clip, which are on the edge of the shelf.
Okay.
Instead of to the cabinet. So if you were to take this shelf out, then you would get no holes because they're part of the shelf.
Right.
Versus the full line boring, as you know, if you don't put a shelf in there, it still has the line boring.
Right.
Said I can have a snack.
Is that clear for everybody? How to do that? Or no?
After we watch your video, probably yes. All right. The other problem that we tackle is build a funky shaped cabinet and have sides of this cabinet, or actually apply partially slanted back on the cabinet.
Say it again. A partial back.
But not but slanted. Let's say like back of the cabinet would not have the same height as the face of the cabinet because there is something on the way or a sloped roof coming down. So the back of the cabinet has to be in an angle instead of full square box.
Okay, so how would we do that?
Well,
Can you switch to a top view for me and draw me the side view of the cabinet you're talking about so we understand.
That is my side view.
Okay. So how could we build that? We did this a long time ago, like the second online session we did, guys.
Yeah, part probably from two views.
How about article from Contour?
Okay.
Let's do it. You're going to apply the contour to the right side view. And you got to give it a name. Snap your parts on there. Okay. So you just need to put a full top on both of the tops rather than rails.
Yeah, that has to be.
Yeah, so your default, this is using your variable. Your default's rails. So you'll want to go pick a top that's a full top. Or make one or whatever. That third one down, CPU TIDO. Third one down, CPU TIDO. Count down from the top. 1, 2, 3. There you go. Same for the other tops.
Okay, and now we found out that in the right side corner, there's 5-inch pipe going through.
Okay. So what do you want to do there? You want to notch that all out?
That's correct. Notch it all the way out because the pipe it's a drain, whatever, and it goes floor to ceiling. So let's say like 6x6 notch in the right side corner.
Okay, well, first of all, draw that up. Okay, so you're in the top view, right? No. Switch back to the top view. So we know we can cut parts in AutoCAD by drawing a polyline, right?
Yes.
That's a good place to start. Okay, so you remember how to do that?
Ooh,
No.
So we need to cut that hole in the two tops and the bottom, or one of the tops and the bottom, right?
right.
Okay, so how do we do that? Well, where's our cabinet?
To the right.
That's it. So details tab, pick those two parts, right? We can get that guy.
If you select a part that it's not on the way of the cutting line, it won't do anything, right?
We'll see. I'm not sure about this angled one. We'll see what happens. Transfer AutoCAD element as inner contour. That's our polyline. Okay. Yeah, didn't cut that part because it's not flat onto it. So we'd have to do that calculation for the flat. Could I figure that out? Yes. And if I can pick that face. Rotate that up so we can see the face of that thing. Robert.
That's what you mean?
Yeah, like that. Quite. Can we do object? think we have our UCS on there. Yeah, I'm not sure that's going to work. We may have to just do a an outline geometry for whatever state this guy is supposed to be. 'Yep. So we're gonna have to do an outline geometry for whatever that is. I don't know how I'd get the part drawn on the face of that. Six, comma six. Not quite what I was after.
I think you have to type at.
Yeah. See if we can get this face. Well, not quite what I'm looking for. Specify other corner. Didn't quite get it flipped over there, did I? All right, let's see this. Not cutting any slack at all, are you? Now. Figure that out. What the hell? Any way to stretch that guy? Can you get that the right size? Damn hard to do.
Where's the option that I can choose? What is it? Multi-line?
That's down here. Tracking settings. This guy.
Oh yeah.
I'm trying to think if there's an easier way to do this.
Yeah, I can get it accurate in 3D space. It's not going the way it's supposed to.
Let me see, is there an easier way to do this? This is a situation where you have two intersecting shapes. It's a Boolean object.
But it also didn't even remove side of the back panel at all.
We can use trims for that.
Actually,
we can just trim the back and trim the side, right? Yeah, so I would say going down this path, oh, come on, piece of shit. To the right side view. I don't know if that's 6, maybe 5.5.
would be 5.25. Well,
I don't know, it depends on if it's penetrating or not. Might be 5.25. Let's see. Yeah. Then I would say we just need to figure out exactly what the shape of this top piece is so we can apply an outline geometry to it. Can I do that? We'll probably see UCS object. Let's align them on the edge. Maybe. Let's do a There we go. Now, how we do polyline. I have no idea how to work, Mike. I think that might be in the wrong corner. Yeah, it is. Well, sure you want to build this damn cabinet, Robert?
Say it again.
Sure, you sure you want to build this cabinet?
Definitely. It happens to us quite often.
where you have an angled top and it needs to be notched.
Exactly. On the third floor, there is a roof coming down, so we are building cabinet, and pipes, whatever, are going up.
Just as a joke,
Okay.
just as a joke. I mean, if we get this slope, I mean, the hard part is done. Take a notch that corner out the bench. That's what we do. Or we're gonna have to draw it. Draw it.
You draw it, then they are expecting to see some sections. So once you have 3D, it's a section now as well.
Let's try it this way. This guy. This guy. Why are you not wanting to notch?
Yeah, right.
No, we got the wrong one, that's why.
If you want, maybe we can practice and give up this and that. No, let's continue something else.
All right, Larry, there's some suggestions.
Yep, hang on, let me get this assigned there.
Because definitely it's not as easy as it looks. So
It's
we think, we could maybe, give you some other problems that we have, and this one we just put it aside and come back to it.
Yeah, I mean, it's going to have to be something along those lines where you notch that top that way.
So I'm assuming that whatever, if there's anything coming down in an angle, cutting through is not as simple as where the boxes are square, sloped.
Okay, so we got it. So that's what you'll have to do is assign an outline geometry to it. You just got to figure out the right size. Not sure we're exactly the right size. We're pretty close there.
Mm-hmm.
See how come that is. .3, so we could redefine this. Oh, damn it. One more shot and then I'll give up, okay?
Sure.
I think the hardest part is figuring out how long this notch is because it's on an angle.
Right.
Down too far. I would think you would have to go something like that to get that done. Definitely not much fun.
And that edge also should go in an angle, right? That cannot be really straight cut.
Yeah, definitely needs some more work, that's for sure. But you're gonna have to figure out what the shape of this top is and draw that and apply it to the part definition so you can get it cut the right size.
Okay, I was hoping it's just as simple as cutting through.
Yeah, no magic on that one.
All right, fair enough. Try about quick break.
All right, sounds like a plan.
Okay then, see you in a little bit. Hey, Larry, are you there?
That's the favorite thing. There you go.
So, Larry, are you there?
Yes, sir, I'm here.
Okay, we're back.
Okay, what's next on your plate?
We would like to know how to remove or make a notch in a park. For example, you have a situation that you have floating shelf and we would want to make a notch in the shelf so we can insert that shelf on a bracket that is coming out of the wall. So basically, 1.5 inch thick shelf made of 2 3/4 pieces, and exactly in the center of that shelf, 2 notches, 4 inches wide by 1/4 inch deep, and let's say notch stops 1 inch, 1.5 inches from the face of the shelf.
Okay, so tell me how that's different from what we just did with that grill. Other than you're not going
It's
all the way
partial.
through.
That's right. It's just partial removal of material.
Okay, so let's make it. Let's do a new top view article. So this is like wall shelving. There's more than one shelf.
We can concentrate on one shelf. Let's say made it from 2 3/4 pieces of plywood.
Okay.
So it's just easier to make the notch. We'll make it on the bottom and on the top of each shelf, and then we sandwich them together, and we have a notch that will receive bracket.
Should put on one part.
Bottom and the top of the shelf.
And then only notch in one part. It'll be easier.
Really suggest.
What we do? We put a notch in the bottom part, and you put top part full. More straight. So you don't have the machine on two pieces with one piece.
Yes, but then you see the notch from underneath it.
No. Notch will be here. That's your center line. So your bracket will be here. It's your top.
Mm-hmm.
You see your bottom. Notch here. So when you put them together, you have a hole.
Oh, okay, but it's still 2 pieces. Only you want to make notch in one of them.
Yeah.
Okay, yeah, gotcha. All right, yeah. So really suggest that instead of not making 2 notches in halfway in both shelves, make only a notch in bottom piece, just deeper.
Okay. Let's do it.
All right, so I believe let it be, and shelf 18 inches.
Well, let's make the height a little taller. You got 2 pieces of 3/4, right? Let's go like 6 inches or something.
But what if we just make machining in the 3/4 piece, and then other piece would be just full shelf, and we just sandwich them later on.
Yeah, I get it.
So it's just the idea is just to make a machining, to remove a little bit of a material in a part.
Okay, but you want it to be in a shelf, and you probably at some point are going to do a full wall of these with several shelves, right?
Yes.
Okay. So make it a little taller so we can make it a shelf. I understand you just want to do the one piece. I get it. Just make the height a little taller. Make it 6 inches. All right, now let's go to divider drawers. Divider drawers, let's put a shelf 1 to 1 in there.
Okay.
Yeah, make it an adjustable shelf. All right, so ellipsis, we need a construction principle, we need a part definition. Let's get rid of the connection situation. We won't need the connection situation. You can do it when you come back. No problem. Okay, so part definition. This will be the routed floating shelf or whatever. New name. Need a name for our part definition, right?
All right, material should be some kind of plywood. Let's go. Okay.
Okay. So again, it's just a groove, right?
Right.
So it's got a groove.
Oh.
Okay. We'll do it. So how far is it run all the way the length of the panel, length of the shelf?
Actually, I want to have it from back to the front and stop, let's say, an inch from the front edge.
Okay, but all
And
the way
then
across the shelf? No.
from side to side, so it'll be two groups. One will be, let's say, 2 inches from the edge, 4 inches wide, and the same thing on the other side.
Okay, so linear division. Start point 2 inches to 1. Let's see, we want 2 grooves though. So start point 2. Yeah, that's fine. We'll just have to do 2 grooves. So 2 inches to 1. And then how far from the front edge?
1 inch.
1 inch to the center or 1 inch space?
1 inch. The groove will start 1 inch from the front edge, or it will stop 1 inch.
Okay, so there's a
Depends
1 inch space.
how you describe it.
There's a 1 inch space between the edge and where the groove is.
That's
And
correct.
how wide is the groove?
4 inches.
That's how long it is, 4 inches. How wide is it?
No. If my shelf is 18 inches deep, front to back, my groove will be 17 inches, and the width of it, 4 inches.
Okay, gotcha. So it's 4 inches wide by 17 inches long and however deep.
And 1/4 of an inch deep, so it will host a metal bracket.
All right, so it's not. It's really more of a rectangular pocket than it's a big groove. Let's do it as a rectangular pocket, not a groove. Get rid of this groove. Open the grooves back up. 3 bars. It's a 3 bars on the right. You see the 3 bars on the right there? Yeah.
Delete it.
Delete it. So what we really want is a rectangular pocket.
Okay.
All right. Yeah. It's more than just a groove. It's a big pocket, right? All right.
Correct.
And it's 4 inches wide, 2 inches from the end. Okay, so start point X, 4 inches to 1 to 4 inches. We want 2 of them.
That's why it would be 1 inch to 1.
No, and Y we want to go to this rectangular pockets go to the center, so it's going to be 17, 8.5, so 9.5 inches to 1. Trust me.
Okay, I'm literally following your.
9.5. What's start point Z?
Two to 1.
On the bottom, what's start point Z?
Zero to 1.
Yep. On the bottom, it's always 0 to 1. On the top, it's always 1 to 0.
1 to 0.
All right, now lengthen X is 4 inches. Just 4. Width and Y, 17. You want a corner radius on it? No?
Something, probably.
Okay. And edge profile will be your tool. So the only thing I see is you forgot your inches on your start point X. All right, save and apply.
Oh, here I'm supposed to change connection situation.
Yeah. Blank that out. You're looking at it from the back, it looks like.
Yeah, that's good. Yeah, that's it.
I'm not sure. Yeah, that is. Okay, let's see here. Hang on, let go. Yeah, looks good. A little odd, but okay. Why is it so wide? Is it, what's this shelf support look like? Like steel tube or something?
Not a tube, but flat 4 inches L bracket. So it's being mounted to the wood stud behind the sheetrock and sticks out front. You know, the size of the pocket and shelf is just random. Usually they are pretty long shelves, and they want to have them floating, so you cannot see how it's mounted. So that would be our, let's say, bottom part. So technically the groove should be on the upper, on the top of it, not on the bottom. But it doesn't matter. You can always flip it over.
Well, so this piece actually goes in between the two pieces?
No, that would be the bottom piece, but you will have to turn it over. So the groove technically should be on top. Then the second shelf without groove will just sandwich.
I got it. So change the groove to the top.
I wonder if this is only the only change, I think.
Nope, you have to change your orientation too. You're still got orientation on the bottom. Set arrow by orientation. There you go.
Got it. Yep.
So how do you attach the two pieces, the two shelves together?
Glue them together, and then put edges all around. Tape, for example, or solid wood, depends if it's between wall or not.
Interesting. And the brackets just slip in, or you glue them together with the brackets in there?
No, the bracket is being mounted to the wall and just sticks out, you know, off the wall, whatever length we need, and the shelf just slides on it with the glue.
Okay, got it. So, I mean, so once again, you can add whatever machining you want to at the part definition level. So the only thing I might change about this,
Usually what we're gonna probably change it will be the size of that groove. and actually position too, depending on the size of the shelf. Oh, that should go through.
Yeah, that's what I'm thinking. Based on what
I
you're
guess I
telling
have to so I have to remove that round at the ends, right? I think I chose
and that's
one
not
eight.
really going to get it. That's not going to get it all the way through. Yeah, that's all the way through. How far are we from the front? That's what I want you to check.
Supposed to be 1 inch.
Yeah, let's check and see. Yeah, it's 1 inch. So why is our shelf? We must have a back set on it. Let go.
What is it?
Yeah, let go.
Mm-hmm.
What size bit are you going to use? 5 as a 1/2 inch?
Probably for quicker removal.
So we need to go past a little bit. .75 and 17.5. I think. I might be off a quarter there. We'll have to see. Much. Come on.
The dimensions of the front edge is not that really crucial.
So yeah, we're in pass now. That should work.
I didn't catch, Larry. What is that 9.5 number from?
So for a rectangular pocket, this works off the center.
Oh, okay.
Not a distance from the edge. So that's why X I said 4 inches, because we wanted 2, and then to the center would be 2 because it's 4 inches wide. So front to back, you need a 17-inch route. So when half of that was 8.5 plus the inch you want here, that makes the 9.5.
Okay.
I just added a quarter to that, moved it back a quarter, and made this a 1/2 inch longer. So it's still 1 inch from the front, but it goes past it on the back. all those rectangular pockets, grooves, rectangular circles, they all work off the center.
Got it.
But again, any machining you want, custom machining you want for a part, you want to go with that part, you can do it at the part definition level.
Okay.
What else you got?
Thinking about it.
Yeah, so you
Nothing
see
new on
what
my list.
really, Robert, what we did here on the shelf was basically the same thing we did for the grill, right? We just added machining directly to a part.
That's true. Yeah. Now, you started out with 6 inches, 6 inches high part,
Right.
if I may call it that way. You basically are asking for a space that you can work with, right? It's
Right,
not
that's
that
all.
in your.
That's all.
Okay.
Like, for example, this one you're talking about, how far off the floor does it go? How high off the floor does this get set?
Well, that all depends. It's not set. Every application is different, depending on room, on what customer wants.
Okay, so give me an example. What would be something you would typically see?
Let's say you have a desk 36 inches and shelf would be at 54 up to, let's say, 72 inches, 2 shelves. So first shelf will be at 54 inches and let's say another one 12 inches higher, for example.
54 inches and then 12 inches higher, so 54 and
So
60,
it's
66.
66.
Then you could change your linear division here to say 54 IN to 1 to 0. So since it's a shelf, we're just giving it a spacing. So
Right. Oh, yeah, I didn't even think about it because when we will draw it, that's what we have to show in our elevation view.
right.
So it's basically, right. I thought that instead of this, I would just bring 2 times the same article, but done this way, it's actually probably easier to control it and modify it later on. If they decide to make space between, let's say, instead of 12, 10 inches, you just go to 1 article and modify the space.
Right. Or maybe they want 3 of those shelves, or who knows?
Right.
But since it's an adjustable shelf, it goes divider drawer, so you can, give it the overall weight you want and then locate it in the space with your linear division, however many you need.
Then you put the electrical piece together with it. So
Oh,
the piece will
just to have a sandwich.
together. Yeah.
So Rudy suggests if we can add 3/4 piece on top of it,
Yeah,
but I guess that
probably
has
do.
to.
Yeah,
But
let's do that. So really, then it's a multiple part. It's got two different pieces to it, right?
yeah, because they have to be treated separately, so we can make a cut. That groove in one of those shelves.
So yeah, you want two cut parts rather than just one cut part.
No, the way it is, one cut part, and the second shelf would be just full shelf because the bottom
Right, but
shelf has
it has to
deep
get
enough
cut
roof.
also. Yeah, it has to get cut also, right? I know what you want. So now it's a multiple part. You're really calling in two cut parts to make one shelf, right?
Okay.
What the heck? Uh, try it again. No groove. This one doesn't have the groove on it. And then you edge band it all as one part, right?
Correct.
So this has no edge. Well, we'll make this. So we need three parts. We need the shelf with the groove, shelf without the groove, and then a part where we can put them together, the multiple part. Is there another one up here somewhere? So remember how we did the miter fold shelf? So it's a multiple part.
Yeah, something.
Yeah. Then we need some construction points. And really we just want them both to be full size. So 0, 1, 0, all the corners. So we need our part definition. Shelf no groove on top. Goes to all four corners, right? Then the shelf with the groove. Also goes to all four corners, but now it's down 3/4. We have our 2-part stack. This one's nice and easy. 1.5 inches thick. So now we get 2 cut parts. Should have gone the other way. Dang it. Oh, I know why. Shell.
So just have to remove. You have to remove the groove from the upper.
Yeah, I thought I did, but maybe I did. Yeah. Let's see. Oh, I forget to take it off.
That's it.
Maybe. Yeah. By making it a multiple part, you can have both of your cut parts and call it up as just one shell.
Mm-hmm.
You want to save that one?
Sure. Is there any other way to save it than just modifying article and then save it?
Nope. Just modify article and save it. 'Cause it's an article designer article. So that's how you save them. You can make you a new folder if you want to.
Yeah, I'm not sure yet. You have to organize it somehow, but at least it's there.
Okay, what else you got?
Don't have anything new, really.
I mean, Robert, I think that you have been exposed to everything you need to make these things, And what you guys are running across is what everybody runs across is, okay, how do I take what I know and apply it to this specific situation? That's always the hardest part. How do I apply that information to what I'm trying to do right this minute?
No, I understand you, Larry. The problem is honestly that we've been so busy that we really, spend minimum time until now. So we just have to start using it more and more. Then we should be good because everything is, kind of logically done, but we need to practice.
Agreed.
Except that angled cabinet that we have to figure out.
Yeah, that one's kind of nasty.
Yeah, and unfortunately it happens quite often, so that's why we have to know how to do it.
Good, and you'll get lots of practice and get good at it. So is everybody spending a little bit of time every day in the program? Well, wrong answer.
I would say a little bit, yeah. Yeah, it's tough now.
Yeah, you've got to devote some time to it every day, or you're just going to lose what you know.
Yeah, I agree. So what I'm thinking, because we lost one day of, one day we missed the our session. So what I'm thinking, if it's possible that we don't do it next week, or we just, I would say, save it and come back to you if it's possible, when we are a little bit, experienced, I'd say.
Yeah, that's fine. Actually, I'm looking at my calendar. I'm actually booked up the next 2 weeks, so the week of the 23rd would be the soonest I could do it anyway.
I think that'd be fine with us, because we definitely need to, put our heads into the software, and then we'll probably come up with more and more problems.
More and more.
So then we could do that could be more productive session.
All right, yeah, no worries. So let's take a couple of weeks and work on some things and try to come up with some ideas of what we need, and pick a day that week. I'm actually booked on that Monday, but Tuesday through Friday I'm wide open, at least for right now. I mean, that could change tomorrow. But...
Right. I guess we'll be in touch, and then we schedule something.
Okay, sounds like a plan. Rudy, are you there? Yeah, so just shoot me an email for today. Yeah, just shoot me an email for today, and then guys start working with it, come up with some more issues you've got, and we'll pick a day that week of the 23rd and do this other session.
Okay.
All right.
Okay,
and,
will do.
Yeah, and I hit Aaron up again today, see what's going on with your Northwood. He's got everything done. He's just having some issue pulling the right tools on the multi-head, trying to get more than one tool to pull right. Hopefully he's going to get that worked out for you.
No problem.
All right, perfect.
Okay, I'll send that email out. Thanks.
All right, awesome.
Last thing, Larry, what about that window that we are getting, that something has to be updated? I forgot. Once we start the wood camp.
Yeah, no problem.
About the new library?
Yep, no, that's just a licensing issue. We just need to get you updated licenses. We'll print those off. We should get those early next week. So you got till the 15th. You should be fine.
Okay.
I'll get them over to you as soon as they come in.
All right then. Thank you.
All right. Anything else, guys? Last minute? All right.
No, I think we're good.
All right, great. Well, you guys have a great rest of the day, and be safe this weekend. And just let me know, pick a day that week, and let me know what day you want to do it.
Okay. We'll do.
All right.
Have a nice weekend then.
Thanks, guys. Yep, have a good one.
Okay. Bye-bye.
Bye-bye.